Now let's put into practice what we learned in the last lesson about using GroupBy. So suppose I would like to find the baby name with sex female that has fallen in popularity the most. Let's just do some exploration with the data first before we get into the details of this. So go over to the notebook, we'll look at Pandas Part 2 and scroll down to the case study. So because I'm interested in the female baby name, first let's just create a new data frame that just has the female baby names. And then I could sort this by year. And then to get some intuition about how we might define the greatest fall in popularity, let's just visualize one name through time. So I'm going to pick Jennifer here. You could pick whatever name you like. You could pick your own name. And we're going to visualize. So notice this is going to use some code that we haven't talked about yet. We are going to talk about this code of how to plot these line plots in a future video. But for now, if you hover over this, it's going to give you the data at each point. And we can see Jennifer really had its prime in Colorado in the year 1977. And if we look at the most recent year that we have data for from this data from the website, it was 8 Jennifers in the year 2022. So one way we could measure a name's fall from popularity is look at the most recent data we have for that name and look at the count. So in this case it'd be 8, and divide that by whatever the count was at its peak. This is not by any means the only way to do this, but this is one easy way that we could define fall in popularity. So let's do that here. I'm going to pop back to the slides, but you're welcome to continue to follow along here in the notebook. Okay, so if we define this new quantity, I'm going to call it ratio to peak. We're going to take the babies born with a given name in the year of the most recent data we have. And then we're going to divide that by the maximum number of babies born with that name in any year. So for Jennifer, we did have data for Jennifer in 2022, and that was the most recent year. And so the RTP was 8 divided by 866. It was pretty small, 0.009. How do we do this in code? So we can do this for, let's just do it with Jennifer first in code, and then we'll come up with a generic function, RTP. So notice to get the max, I am going to be selecting the max from the Jennifer array. And then if I want to get the most recent number of Jennifers, really what I'm going to do is take the Jennifer array and then take the very last entry. Because that may or may not be 2022. In this case it is, but there might be some names where the most recent data we have for them was, say, in 2020. And then I take the ratio of those two. So now let's formalize this and actually write a function that will do this for any name. So it's going to take in a series, which will be a name series, a count of a given name, and then it's going to return this ratio to peak. And so notice, if I create the Jennifer count series and then pop it into this function, this is just a double check that all of this works, and I can see, yep, this is working how I would expect it to. Okay, so now let's use GroupBy to help us calculate what we need. So here, I can group my baby names by the name, and then I'm just going to select the year and the count to start. And we'll talk about exactly what columns we need, but right now I'm just going to select those. And now I'm going to apply the ratio to peak. And so notice that's going to actually apply ratio to peak to both year and to count. And so here's what I get out. So one thing I want you to think about is in the 10 rows that I've shown here, the year is 1 for every value. And I want us to think about why that's coming out and take a minute to decide whether or not are there going to be any rows for which the year is not 1. So take a minute and think about that. Okay, so the answer is no, and let's think about why. The way we've defined ratio to peak is it's going to take the last, if you think of this as my series of count data for a given name, it's going to take whatever the value is in that last entry and then divide it by the max. If this is a series of years, so these are going to be years now, it's going to take whatever year I have the last data for a given name, because I've grouped on name. So it'll take the last year that I have data for, and then it'll divide that by the maximum year. Well, we have this sorted in order of year, and so the last year that I get will be the max. So this is always going to be 1. You can play around with this some more in the code. Note that if I hadn't selected a subset of columns, I would get an error, and that's because I can't apply ratio to peak to all the columns in my data set. So that's really why I needed to select a subset. We can see it wasn't even necessary to select year, so let's just grab count. That's really the one that's going to be indicating what we're interested in. And now I have count, and then I've aggregated it by ratio to peak, and so now I really want to look at which ones were the smallest, because that's going to have my biggest drop in popularity. Again, I had mentioned this in the previous video that when you group by, it doesn't rename any aggregated columns, so to make it more readable, it's definitely recommended to rename. Okay, so now let's sort, and now we can see, aha, looks like Linda fell the most in popularity, followed by Deborah, then Amanda, then Jennifer. Oh, so Jennifer was one of my lowest ones. I'm plotting Linda, and we can see, yeah, Linda had a pretty steep drop off here. And I can actually plot the top 10 names that fell in popularity. And so if let's actually scroll back over to the notebook, because then it's more interactive with this plot. If we scroll down and just run these here. And then, oh, that's giving us the warning that we talked about. Let's do that one. And then we'll plot this top 10. Oh, this one's mad because I did not rename it. Yes, I should just run all of these, as I assume you have been doing. Don't try to skip the cells. There we go. All right, yeah, let's plot these. And there we go. So that's pretty fun to see, and then you can actually just scroll over them and see exactly. So yeah, Linda really went from 1948, oh, sorry, a count of 1,037 in 1948, and then a major drop off in 2020. So have fun with this. You can put in your own name or your friend's name and just see how they may have changed in popularity over the years. Okay, let's give you another puzzle. This time I want you to write code to compute the total number of babies with each name, and then code to compute the total number of babies born each year. So the first one, if we look at what we did with our ratio to peak, it's a similar idea. It's just that instead of taking in the count data and using ratio to peak, I'm just going to sum it. So I could do either of these calls and I will get this return. For part B, I'm going to group by year because I want the number of babies in each year. And then again, I'm still summing on the count. And in both of these, I will point out, I don't think we use the dictionary. Yeah, the third way we could do this exact thing is to keep this here, but then do .ag and write the dictionary form where I'm taking count and then telling the function I want. That's the third way we could do this. So any of those will work. Now, I want you to notice if we plot the data frame you just generated, it's telling an interesting story. This is the number of the baby names in Colorado, based on our data from when we first started in 1910 all the way to 2022. And what's interesting about this is if you look at the babies in, let's say, 2020, our plot shows around 46,500 babies. But if we actually look at some real data for babies born in Colorado, I just went to the Colorado Health website, it shows more. And so I want us to think about what may have happened. And this is a really important step in data science, is to do a gut check on your plots and what your outputs are. And part of this brings us back to the data science lifecycle, which is thinking about how is our data organized and where do we get this data from? So just blindly saying, oh, well, this must be right, is a dangerous way to go. And this brings us back to where we got the data, which was from Social Security database. And so there were two pieces to keep in mind here. The database did not include names that had less than 5 babies born in a given year with that name to try to keep the data anonymous. The second thing is not all babies are going to register for Social Security. So those are two reasons that we have been undercounting using this data. All right, let's move to another data set. We're going to go back to the elections data set for the next few problems. So this is just a reminder, this is data from US elections, including the candidates, the party, and then the percentage of votes and the number of votes they got. And I'm going to show you on the next page a way you can peek into the group by functionality. If I want to group by, for example, party, I can then call the attribute.groups, and it will spit out for me the groups and their data. So this is a little bit harder to see. You could do groups by party.get groups for a specific one. This will be a little bit easier to see. And now it's, yeah, so when it's, sorry, when I said it's spitting out the groups and their data, no, it's the groups and the index values associated with entries in that group. If you want the actual data, you're going to then call .getGroup and then whatever group name you want. So that is one way you can look under the hood at a given group, especially if you're getting kind of weird results. All right, here's your next puzzle. Notice when I call group by party and then I do ag max, it seems to claim that Woodrow Wilson won the presidency in 2020 because I have, So what could be going on here? Take a second, put it on pause, see if you can figure out what I did wrong. Okay, a big issue and a big caveat is to remember when I call it .agmax, it's going to aggregate each column individually. So it's taking the max of each column independently, and that is why the last year that they ran, 2020, is what was showing up here among Democrats. And then it was going alphabetically by the latest name, which was Woodrow Wilson, and then it was looking at the highest percentage of votes. So there is no relationship between the entries in this one given row. So let's suppose I did actually want to get the best results in percentage by each party. So I want to know what was the election in which the Democrats had the highest winning percentage, which was 61%. That happened in 1964. The candidate was Lyndon Johnson. This was the popular vote. So all of this data is one row. It is consistent with itself. How could we get this information out? So if you said, oh, why don't we use the dot first functionality, that is actually the fastest and easiest way to do it. If you first sort your data set by the percentage of winning, you'll have to set ascending to false, and then you can group by party and just grab the first of each group. That will work. Here's my elections sorted by percent, and so you can see here, just in the top two, just because Democratic was showing up that way, it's just going to pull that for the Democratic category, and then for the Republican category, it's going to pick Richard Nixon. So I can see that, oh, it doesn't show up because this data set keeps going ... But this would be what's showing up in the table here. That's one way you can do this. There's actually quite a few ways to do this, which is commonly the case in pandas. So another way you may have thought was, well, I could do a lambda function, which would work as well. Once you've grouped by party, again, once I've sorted, grouped by party, instead of calling first, this is basically what first is doing underneath the hood. It's taking the first entry in each subdata frame. There's also an index max function, which I'm just pointing out here because it may be useful in the future for you. And in that case, it's once I've grouped by this and I look at percentage, this is just going to tell me the max index in a given group, and then I'm grabbing those. Or I could do this by sorting the values first, right? Because that has all of them. And then I could drop duplicates. So that will just allow me to keep. This case I'm keeping last because the sort values is going to go ascending. And so I really just want the largest percentage. So any of these will work for the same puzzle we were thinking about. I do think the dot first was the quickest and easiest in terms of what's already built into pandas. And lastly, let's try a puzzle where you're going to filter. So if we want to only keep election years where the max percentage is less than 45%, I'm going to group by year, and I'm going to create a filter where it's looking for the max being less than 45. I can then, this is just kind of nice just for sorting. I can then set my index to year and sort from there, but it's not necessary. I didn't actually include that in the puzzle prompt, so you would have been fine also just stopping there. This is what's happening when I'm doing the filter originally. Oh, yep, and then the last piece was just nice in case I wanted to sort by year. Okay, so at the end of all of this, what I want you to take away is there's always going to be more than one way to get the same answer, and there's going to be trade-offs. So if you find your current solution is particularly challenging or convoluted, try not finding another way. But this is part of the learning process, and we encourage you to try multiple approaches to the problems that you'll face.